Hello everyone. Today is November 2nd and we are getting ready to lecture over section 6.2 today, and that is about simplifying these radicals. Our objectives are to write the radical expressions in simplified form, and objective B is to rationalize a denominator that contains one term. All right, so that's what our goal is today. So let's start off with simplifying a radical. And that may be, this is practice problem 1 now. And what we have is the square root of 18, and we want to simplify that. So what I like to do is take the 18 off to the side and give me two factors of it, and that's going to be 9 times 2. And then I could break the 9 down to be 3 times 3. Okay, these are all my prime numbers now. So this is like saying, what is the square root of 3 times 3 times 2? And then what is it? Since the index is 2 for square root, for every 2 of the same number, I want to take 1 out. So here I've got 2 3s, and I want to take 1 out. And then what's left inside is the 2. So my answer is going to be 3 rad 2. 3 radical 2, or 3 square root 2. This is it. I can't do anything with that 2, therefore it stays underneath the radical sign. Okay? Let's add some variables to the next one. This is practice problem 2. And this problem's going to be what? I'm going to have the square root of 50 x to the second and y to the third. And again, I'm just going to blow up this whole thing altogether. 50. And that's going to give me 25 times 2. And the 25 I can break down to be 5 times 5. So here are my 3 prime numbers. And then I've got, well, let's break this up. So it's going to be, I know I'm a little dramatic about this, but I want you to know how to do it with confidence. So this is going to be 5 times 5 times 2, and then times x times y to the third, which is y times y times y. And now I'm looking at the index number. I know it's 2. For every 2 of the same number, I'm taking 1 out. So here, let me scoot that over a little bit if I can. So I got 2 5s, so 1 comes out. And then I only have 1 2, so you know that's going to stay inside. I have 2 x's, so 1 comes out. And then over here, I've got 2 more y's, and 1 of those comes out. Okay, everything's out that I need to, and then I got to put back what stays inside. And that's going to be this 2 times y. And this is my answer. It's just kind of fun doing it this way. Makes you give you a deeper, richer understanding by doing it manually this way and breaking it down. Then once you get on your way, then you feel good about it. Then you can go ahead and take further shortcuts as you see fit. Okay. Practice problem 3. A little bit different, but the process is still the same. I want to take this 54, bring it over to the side, and do the prime factorization of 54. So let's see, that's like saying, what is 9 times 6? First 2 numbers I think of that I know equal 54. All right, so the 9 I'm going to break down to be 3 times 3. And of course, these are prime. And the 6 breaks down to be 3 times 2. Okay? So then I've got the a to the 4th and b to the 3, so let's have this fun here that I like having. It's going to be the cube root of these numbers. 3 times 3 times 3 times 2. 27 times 2. Okay, then I've got times A times A times A times A. And then how about times B times B times B? Okay, so that's the extent of it. My index number is 3. So now I'm going to say to you, for every 3 of the same number, we're going to take one out, or variable now in this case. So here's 3 3's, and I'm going to take one of them out. I only have 1 2, so that's going to stay inside. Here I've got 3 A's, so I'm going to take one out. And here I've got 3 B's, and one of those come out. So I've got 3 times A times B, and then I'm going to put back what's left over, which is this 2. And then I've got an A here. B's are gone. I took those out, and this is my answer for that problem. Okay, isn't that very cool? Take your time. Don't rush. Where are you going? To work, probably. All right, let's do number 4. I'll turn this off for a minute. Be right back. Okay, we've got 2 problems for number 4. Let's do this first one, where it is the square root of 75x to the 5th, y to the 8th. Okay, so it's going to be 75 comes out here. Prime factorization, which is what I think of as 25 times 3. 3 is already prime, and the 25 breaks down to be 5 times 5. And circle them. Then I've got 5 x's and 8 y's. We may want to do a little shortcut way here, but let's do it this way. Here's my square root, and then I'm going to put inside is 5 times 5 times 3. That's my 75. And then I've got x times x times x times x times x. There's 5 of them. And then 8 y's times y. That's 4, 5, 6, 7, 8. Okay. And let's go to work. I got 2 5's. That's what my index number is, not written. 2 5's, so 1 comes out. I've only got 1 3, so that stays. Here's 2 x's here, so 1 x comes out. Here's 2 more, so I could list it here, or I could just square it as well. That's 2 x's that are out. And then this x stays. Here I've got 2 y's, so 1 comes out. 2 more y's, that 1 comes out, so I'll square that. Here's 2 more y's, and that's going to be to the 3rd. And finally, 2 more y's here, which makes this y to the 4th. Okay, so let's do it this way for myself anyway. 4. Okay, remember now that was x to the 5th, y to the 8th, and let's pick on that y to the 8th. If I want the square root, there's really a 2 here. This is just to show you a shortcut. 2 goes into 8 4 times, and that's what I get here, y to the 4th. Just remember that they're exponents that you're doing the division with. Okay? And notice 2 goes into 5 2 times. Here's my x to the 2nd, and 1 left over. That's here. We leave that inside. Okay, just to throw that up at you. All right, and then for our answer here, what's left over is the 3, the x, and all the y's are gone. So I got 3x here. Okay, so that is the first part of practice problem 4. Let's see, how about the next one? Let me shut this off. I'll be right back. Okay, so now here, I'm dealing with the 4th root of all these here. So let's do the 48. That would be like 6 times 8. And they can be any two numbers that multiply to be 48. And then I want to break down the 6 first. So that's going to be 3 times 2, prime, prime. And the 8 I know is going to be 3 factors of 2. So it's 2 times 2 times 2. All right, and I'm just circling these. And now this is what I've got. And now just to shorten my work a little bit, I'm going to take the 4th root, so I'm not writing these over and over again. So I'm going to take the 4th root of these numbers, that's the 48, and do my thing. So I'm going to say what? I got 1, 3, but then I've got 1, 2, 3, 4 2's here. So these 2's, 4 of them, 1 of them comes out. All right, so I'm going to bring it over here. A 2 comes out, and then a 3 is left over. Remember, this is the 4th root. So the 2, I didn't do that right. Hold on a second. I don't want that yet. I want this. I took 4 2's, 1 came out, and then here I've got my 4th root index number. And then let's look at our variables now. So I can say 4 goes, is anything left here? The 3 stays inside the radical. I'm anxious to get to the variables. All right, so I had 4 2's, took 1 out, the 3's left over, so I'm putting that inside the radical. Now I've got a to the 8th. Well, 4 goes into 8 2 times evenly, so this is going to end up being what? A squared. A squared on the outside. So it's going to be 2 a squared. I'll get rid of that. I don't want to confuse this. Okay, and then I've got 2a squared. And how about 4 goes into 5? 4 goes into 5 one time. So that means 1b comes out and 1b stays in. Okay, so I've got the 3, and then I'm going to put a b here. And then the c 4th, they all come out, right? I have 4 c's. 4 goes into 4 one time, so the c comes out. And there are none left over. So these are all outies here. And then what's left inside of this 4th root is the 3 and a b. And this is my final answer. Okay, a little bit dramatic of a problem. Let's move on. All right, check these out. Now I have the square root of 5 over 9. So what I like to do is take these and separate them. And I can say, what's the square root of 5 over the square root of 9? Okay, if I do that, I can look at the square root of 5 is just the square root of 5. I can't simplify it. So that remains the square root of 5 over the square root of 9 we know is 3. So there, this is how this simplifies. And then we're good with that. Okay? In this next example, we're going to be doing what is called rationalizing the denominator. For there is a rule where I cannot leave my answer with a radical in the denominator. It is not allowed. All right, so if I just have x here. I'm making this up now. All right, if I have a denominator that has a radical in it, I have to rid myself of that radical in the denominator. And the way we go about doing that is multiplying the top and bottom by 1, which is in the form of the same term over the same term. So what I want to do here is I want to multiply top and bottom here by the square root of x. And the top would be the square root of x. Okay, when I multiply the square root of x times the square root of x, my answer is just x. And when you think about it, if you can multiply the radicands that's inside the radical sign. So that would be like saying this is really the square root of x squared. X times x is x squared. And then my numerator is just x times the square root of x, which would be x times the square root of x. I won't bother with that. All right, what's the square root of x squared? Well, it's x. And then my top would be x square root of x. And then I can keep going on this particular example by the x's can cancel out since they're factors. Okay, excuse me a moment. Okay, sorry about that. And anyway, where I ended up was taking my x's, and I can cancel those, and then you're left with square root of x. That's just an example of what can happen. All right, when we rationalize the denominator. So let's go to an example again, and this one is this is number 6, PP6, and we've got the square root of 2 over 3. Okay, so what I want to do is I want to split these up. I want to say what's the square root of 2 over the square root of 3. All right, now I've got my denominator has a radical in it. I can't do any simplifying other than that. So I've got to multiply top and bottom by the square root of 3. Like so. So my top is going to be the square root of 6. 2 times 3 is 6. And then this is going to be the square root of 9. Okay, so the square root of 9 will simplify just to be 3. And see, the radical sign is gone. And that's what I want. And then I leave the square root of 6 alone. So this is my solution for whatever number that is, practice problem 6. Okay. Let's see where we can go next. How about it? 5 over root 2, we got to rationalize the denominator. So I'm going to multiply top and bottom here by the square root of 2. And that's going to give me 5 times the square root of 2, which I just write as 5 root 2, because I can't simplify it or join any factors this way. And this is going to be all over 2. The square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 is 2. But you can see that pattern developing. You know, I could say, here's something here for you. Totally unrelated. Here's the answer to that problem, okay? So we're good with that. This is a different sidebar. So I got the square root of 100 times the square root of 100 equals how much? Everybody, at the same time. The square root of 100 times the square root of 100 is 100. Okay. Okay, another one. Rationalize the denominator. So I'm going to multiply top and bottom. Let me get rid of that. Top and bottom by square root of 2y. Square root of 2y. Wow. So that's going to equal I know my denominator is going to be 2y. And then my numerator here is going to end up being, boy, let's do these radicals first. So that means it's going to be the 3, I bring the 3 over, like 3 times 1. And then here I've got the square root of 5 times 2 is 10. X times y is xy. And by golly, that's it. That's all we have to do with that. That's all we can do with that one. I can't take anything out of the radical sign. Okay, fairly easy. Okay, check this problem out. We're going to change gears now because we're rationalizing a denominator with a third root in it. So what I wanted, there's 2 ways of doing this now, depending on what the denominator is in the radical. So I could say, I could look at this and say that this is really 3 to the 2nd power. if I wanted to rewrite that. This would say what is that? The 5. Let me get rid of that a moment. I've got it 5. Not the square root. Come on. I've got the 5 over the cube root of 3 to the second power. Now, because I'm dealing with a third root, I've only got 2 3's there. So I've got to multiply it by another square root of 3. Okay, so let's see. That means I'm going to multiply this top and bottom by the square root of 3. Because this is 3 to the first power. And 3 squared, I'm just working on let me write this here so I don't forget. I want to make this a cube number in the denominator. Okay, so that means I'm going to have the 3 squared times 3 to the first is 3 to the third. Okay, if I have 3 to the third power here, now I'm okay because my denominator is going to simplify to be what? For every 3 of the same number, I take 1 out. So I'm going to have 3 3's there. This is like 3 times 3 times 3, right? And now I want the cube root of 3 times 3 times 3. Well, for every 3, I take 1 out. So that 3 is going to be in the denominator, like so. And it's going to simplify to be just a nice 3. Because I multiplied it by an additional 3 in these denominators under the radical sign. My numerator is just going to be 5 root 3. That's all I can do with that. And I got 5 over 3. I can't simplify the 5 over 3, so this remains my answer. And notice I got rid of the radical in the denominator. Okay, the other way of doing that same problem is, let's see, I'm going to put this back, put my problem back, and I'll take that out too, and say the cube root of 9. Now another way of going about doing that is writing this up as, and multiplying the denominator by the cube root of, let's see, 9 squared. Or I could say 81. I'm going to use the 9 squared part because I can see then I have 3 9's there. Okay, so what do I get from that? I'm going to get the cube root of 9 times 9 times 9. There's 3 9's there. This is 9 to the first power times 9 to the second power is 9 to the third power. And then I'm saying, what is the cube root of 9 times 9 times 9? Well, it's 9. So I got 9 in the denominator. I'm going to put it up over here. 9 in the denominator. And if I do that to the top and the bottom, remember the bottom is the cube root of 9 squared, then what have I got? I've got 5 and the cube root of 81. 5 times the square root, the cube root of 81. And I could break this 9 squared down to be 3 times 3 times 3 times 3, because there's 4 of them, 2 of them, which makes 4 of the 3's. Okay, now I'm saying what's the cube root of this? So the 3's of the same number, I'm going to take 1 out. So here's 3 3's, and I'm going to take 1 out, and that's going to come over here. Wow, you really got a mess going on here though, right? This is what I'm working on at this point. Okay, if you're okay with that. And so then I end up with, what do I end up with here? Let me do some erasing perhaps. Okay, let me get that out. You can just dial back if you need to see that again. So what I've got here is a 3 times 5 over the cube root of 3. So all this ends up doing, well, I can simplify this. 3 goes into 3 once, and 3 goes into 9 3 times here. Okay, and notice what we have for our answer. I'm going to have 5 cube root of 3, and that's going to be all over 3. And I believe this was, I erased it. That was the same answer we had before. And that's kind of neat. See if I can go back to that. Erasing that. What did I have? Working all that over. Nope, I can't go back that far. But anyway, that's what I ended up with. Okay, so that was the other way of doing it. I had the cube root of 9. I did the square root. I feel like I got to do this again here. That is right here. And that was my explanation for it. And how we got to that answer. Ended up having the same answer for both of them. Okay, so I had the denominator here was going to be the cube root of 9 times 9 times 9. And then remember, I'm doing it top and bottom, cube root, and I could say 81 here or 9 squared. Really doesn't matter. But my top was going to be 5 times the square root of 3. And what else? Oh, I guess we have to go back and look at that because I had another 3 here because this broke down to be 3 times 3 times 3 times 3. So the 1 3 came out. And then down here I had the cube root of 9 times 9 times 9. Every third, for every 3 I take out 1. So this becomes 9 down on the bottom. And again, I'll do it this way. Then I simplified it. The 3 over the 9, and I ended up with 3 goes into 3 once, 3 goes into 9 3 times, and this ended up being the solution. 5 root 3 over 3. Okay. Next. Okay, let's simplify the square root of 48x to the third, y to the fourth, over 7z. All right, so first thing I want to do is I want to separate the two. So here I've got the square root of 48x cubed, y to the fourth, and that's going to be over the square root of 7z. Okay, now I suppose we can maybe simplify that up top there since it's a square root, but let's try and just rationalize that denominator first. Let's see what happens here. I may be creating more work. So here I've got the square root of 7z, and that's going to be over the square root of 7z, which tells me my denominator is just going to be 7z. Okay, my numerator here is going to be, well, I'm not going to multiply it out, but I'm going to end up having the square root of 48 times 7, not multiplying that together, x to the 3, and y to the fourth, z to the z, just z. Okay, here's where I'm at. Now I want to figure out what the square root of my numerators are. Okay, so let me slide up here. So let's see, I've got 48 times 7. Well, I know the 7 will maybe stay there. How about I've got 48? 48 times 7. Let me do it this way. 7 is prime. 48 breaks down to be 12 times 2 times 2, because that's 4, and 12 times 4 is 48. Prime, prime. The 12 breaks down to be 2 times 2 times 3. That's 4 times 3. So I got 2, 2, 3. Okay, so underneath my I'm just taking care of my radical sign here. It's going to be 2 times 2 times 2 times 2 times 3 times 7. I've included that 7 in it. Okay, so I've got 2 times 2 times 2 times 2 is 16, times 3 is 48 times 7, so I'm doing okay. And now this is the square root of that, 48, and so for every 2, I'm going to take 1 out. Here's a 2, and here's another 2, so that'll give me 4 on the outside. And what's left inside is the 3 times 7, which is 21. Okay, and now let's take care of the variables. The square root of x to the third. Well, if I have 3 x's, right, x to the third, for every 2, I'm going to take out 1. So I got an x on the outside. Let's put it next to this 4, and 1 stays inside. Okay, next I've got y to the fourth. And that's y times y times y times y, the square root of that. So you can see I'm going to have 2 y's coming out. So I'm just going to stick it over here, then I'll rewrite it. And that would be y squared. For every 2, take 1 out. So here's 2y, so a y comes out here. And then here's another 2y, so another y comes out here. Y times y is y squared. So that's out from underneath the radical sign. And then the z, well, I only have 1 z, so that's forced to stay inside this z here. Okay, you're good with this? And then lastly, this is all over 7z. So I could rewrite this as 4x y squared root 21xz all over 7z. And I can't simplify 4 over 7, and nor do I want to cancel the z's here, because this z is still under the radical sign. So this was a pretty challenging problem, and that's the answer for that one. Okay, very nice. I hope. Now for these next few examples, this is kind of like a little code talk here, especially on your homework. You don't want to, you want to understand what's going on with it so you can get to the answer quickly. But I urge you to all read on page 528, please, and that'll help you with it other than my explanation. And the examples here that they're giving us, or the practice problems, the absolute value property for radicals. And remember at the beginning of this chapter, I talked to you about the square root of x squared, and the fact that that could equal x times x, or it could equal negative x times negative x. Okay, both giving me the answer to the square root of x squared, which is x. Okay, but now they're adding in this little direction here. Probably in example 10 you can see it. It says simplify each expression, but do not assume the variables represent positive numbers. So I have to take care of this in a way that's mathematically understandable to the reader. Okay, and that is using the absolute value bars. So we want them to realize you can have it as a negative variable, but your answer is going to be enclosed in the absolute value signs, which is the two bars that go straight up and down. And because it's saying do not assume the variables represent positive numbers. If we assume that they're positive numbers, then we can just leave it as x. But if we cannot assume that the variables represent positive numbers, we have to enclose them in absolute value signs. Okay, hold on again. Popular guy. Okay, so here's an example of what I'm talking about, where you'll run across the direction in a problem and it just says simplify each expression. So if I've got this type of a problem, I'm just going to assume that they mean the variables are positive. All right, so then I just write it up as 4x. The square root of 16x squared is 4x. Okay, then I'm simplifying it. It's assumed that they're positive. My next example is this way, where it's saying simplify each expression, but do not assume the variables represent non-negative numbers. Do not assume the variables represent non-negative numbers. So now my answer for this one changes to include the absolute value sign for the variable. So this is going to end up being 4 times x, but the x is enclosed in absolute value bars. And you do that when you have this direction. They're telling, when they have, especially, do not assume the variables represented. That tells you to use the absolute value bars. And that's all this is about, trying to convey that to you so you know why are you getting that problem wrong, or, half wrong, whatever they allow for you. All right, so let's try another one here. If I have the 25x squared, same thing basically, just a different square number. Is that a, what is that? Okay, let's try this one. So here I've got 25, so this is going to equal 5x, and the x we're going to take and enclose it in the absolute value sign. Okay, hold on a minute. Okay, so I think I finished saying what I'm saying, so we'll move on to the next one, which is going to be the square root of x squared minus plus 10x plus 25. Okay, so now I've got to factor this. This looks like a perfect square trinomial. So if I factor this, let's do it this way. X plus 5. And then I'm saying, what is the square root of this? For every 2 of the same terms, I take 1 out. So in this case, it's going to be x plus 5. But the caveat, remember the directions, do not assume the variables represent positive numbers. So I have to put this binomial, the whole binomial, in absolute value bars. Because this is x plus 5, it goes together. The others, the x was just a variable, so it was a factor, so I could separate it. Okay, so this is what's happening here. Let's see if we got another one I can help with. All right, so therefore on this problem, we want to factor this. We can take out the x squared, it looks like. So if I do, it's going to be the x squared comes out front, and then I'm going to put back what's left over, which is 2x plus 7. Then if I take out if I look at my problem in this way, now I can see that the square root of x is x, so that x comes out front here, and I'm left with the inside, because that's just going to stay as 2x plus 7. There's nothing I can do with that, so it remains as part of the radicand. Okay, and the x, therefore, again, because of the direction, has to be put in absolute value bars. Okay, and that's taken care of. The do not assume that they're positive. It could be a negative, but if the absolute value enclosures, it makes sure that it turns to positive. Okay. Next. Okay, here's practice problem 11. We have two of them basically, but they want to know what's the third root of negative 3 to the 3. And yeah, two different ways of looking at it. You know, that you can do my, really expanded way where I'm expanding negative 3 to the third, which we know is negative 3 times negative 3 times negative 3, right? And they're asking for the cube root. So that means what? For every 3 of the same terms, I'm going to take one out. Well, there's 3 negative 3's. There's 1, 2, 3. So for every 3, I'm taking one out, and that's negative 3. That's it. If I change the radical expression here into the ratio of an exponent, the exponents where they are ratios, which is a fraction form of an exponent, then this would be negative 3 raised to the, what do we say, the index number was the denominator, and this 3 here is the numerator. So it would be negative 3 to the first power, because 3 over 3 is really the first power. 3 over 3 is 1. So I end up with negative 3. Okay. And they give us one more here. The same thing going on. And my answer for this, well, what do you think? Based on the previous two examples, they're both raised to the third. I have 3 of them, so it's just going to be negative 1. That would be my final answer for that. Okay, that's it for today. I hope you enjoyed this. It was fairly easy. If you know your facts real well, you shouldn't have a problem. And use your calculator whenever you can. I know sometimes you can't, but for the most part, learn this, understand it, so then you don't have to depend on the calculator. You can just get the answers and get them right. But I will warn, and you'll have practice or have homework problems for it with that verbiage in your directions to say, simplify them. Do not assume the variables represent non-negative numbers. You have to put the variable in absolute value bars. Okay, thank you. Have a good day.